Hi everyone. We're starting a new unit today, Unit 8, quadratic unit. It takes up pretty much the rest of the year. We divide it into two pieces. The first piece of the unit is going to feel like a lot of skills. The second piece is going to bring in the applications. Today, it's going to feel like a really big vocabulary lesson and with a little bit of adding, subtracting thrown in at the end. So today we're going to do adding and subtracting of polynomials. It's chapter 9 in your books, section 1. But first of all, we have to get some vocabulary under our belts. So first of all, a single algebraic expression that is a number or a variable or a product of a number and a variable, or z, is called a term. And I've given a bunch of examples here. We've worked with terms throughout the year. There's a 3x, a 2x squared, negative 12xy, the number 7. Those are all called terms. Now, when you take those terms and put a plus or a minus in between them, we're going to have a new term, which is called a polynomial. Poly means many, and nomial is like another way of saying term. So if you have an expression that is either the sum of one or more algebraic terms, and again, subtraction can be the same thing as adding a negative, you can have a number in front, a coefficient, like the negative 4, and our exponent here is a non-negative integer. Let me explain what that means. So polynomials, by that word non-negative integer, the integer part says there can't be any fractional exponents, so we're not going to have any roots. We're not going to have anything that looks like this guy. That's why he's got a red oval with a line through it. That is not a polynomial. The other thing that polynomials can't have is a negative exponent, which means that we're not going to have a variable in the denominator, like x to the negative 1 would put this guy in the denominator. So all of our exponents are going to be positive integers, or they could be 0, because that would give us just a number without a variable. So that's what a polynomial is. It's a many-termed expression. And now we're going to learn a couple more things. So first of all, I'm going to go down here, and you're going to look at this one right here. And this one is in what's called standard form. Now, standard form of an equation is where the terms are placed in descending order from largest degree to smallest degree. So let's just stop there for a second. What does this term degree mean? The degree is the exponent of the variable. So if you look here, we have the x to the third in front of the x to the second, in front of the x to the first, in front of the constant. And remember, the constant could have an x to the 0, which would be 1. So all of our exponents are going in descending orders. So that's what it means by largest degree to smallest degree. And we have no terms that have the same degree. So if you look here, there's a 3, there's a 2, there's a 1, and then of course this would be the 0. Now if you look up here, there are two examples that are not in standard form. So look right here, they're going up in order rather than down, with the x squared being at the end. You'll remember I always say let the constant be the caboose. I kind of had my eye on this when I was saying that to you. And if you look over here, this one also is not in standard form, because look at these two guys. They have the same degree. They're like terms. We should be combining those. 6x minus 3x would give us a 3x. So just to remind you that that little number is called the degree of the term. Now, the degree of the polynomial will be the largest exponent. So this would be a degree 3. And the leading coefficient of the highest exponent is called, the leading number is called the leading coefficient. So there's the leading coefficient. It would be 4. This one is in standard form. The degree of the polynomial would be the 3. And oh, by the way, the constant is the caboose. So standard form, make sure your exponents go down from largest to smallest. That's called the degree. The degree of the polynomial is the biggest exponent, and the number in front is called the leading coefficient. Now we're going to start naming these guys. So here comes some major vocabulary. So if your highest exponent, so look at these two, they're both don't have a variable, which means it would be an x to the 0, no variable. Those are called constants. No surprise there. If your highest degree is an exponent of 1, so x to the first here, x to the first there, that is called, oops, let's put that back. Sorry about that. There's the box. It's called linear. Think of y equals mx plus b, right? The x had a degree 1, had an exponent of 1. Now, if we look at our largest exponent, notice this guy is in standard form. Notice it's a 2, and it's a 2 here. We learned this back in our function. That is the quadratics, and that's what we're going to be working on in this unit. If we take our highest degree on the variable of being a 3, notice it's a 3 here. You might remember this name from our function families. It's a cubic. Now, your book doesn't have the next one, just to let you know, but if there is a 4, it's called a quartic. And if you think of 4 quarts of milk in a gallon, that might help you remember. And then once we go past the 4, we don't have special names. We just call them 5th degree, 6th degree, 7th degree, that type of thing. So that's kind of like giving the polynomial a first name. But of course, we can also have a last name. So you're going to classify, you're going to name it by degree, which is what we just did here. But then how many terms are there? So notice there's one term in both of these. Notice there's 1, 2, x and the 5, or the x squared and the 9. There's 2 terms. Down here you see 1, 2, 3. Remember, the terms are separated by either additions or subtraction, and there's 3 over here, and there's 4. Now, this was kind of like their last name. So if they only have one term, they would be a monomial. If they have 2, and think about mono means 1 for a prefix. What would be a prefix for 2? Think of the thing that you ride that has 2 wheels. It would be a bicycle, so binomial. And then, of course, a little kid would be with 3 wheels. It would be a tricycle, which would be a trinomial. And then once we go past 3, we pretty much just label them polynomials. So what I'm going to show you in the next slide is how we put the 2 names together. So let's take a look again. Look at this guy. He has what degree? He is a degree 0. He doesn't have a variable, 0 variable. If it was there, it would be x to the 0, and it would become a 1. So his degree name would be a constant. How many terms are there? There's just 1, so he's a constant monomial. Down here, we have an x to the first, so his degree is a 1. So by his degree name, his first name would be linear, and there's only 1 term, so he would be a linear monomial. 7x plus 1, the biggest exponent is 1, so that's the degree of the polynomial. There are 2, oops, sorry, I forgot to give you his name. He's linear as well because his degree is 1. And then there are 2 terms, so he would be a binomial, so he is a linear binomial. The degree of this polynomial, the biggest exponent is 2. His degree name would be quadratic, and he has 1, 2, 3 terms. He's a quadratic trinomial, and that is going to be something we're going to work a lot with coming up in the future. Highest degree is a degree 3. His first name would be cubic. How many terms does he have? 1, 2. So he's a cubic binomial. Highest degree is a 4. This one is not in the book. He would be named a quartic, and we are beyond the trinomial, so we would just call him a polynomial. Just going to throw this last one in. We really don't work with it in Algebra 1. You will see it in Algebra 2. But if you have multiple variables, you would kind of just add those 2 together. He would be at what's called a degree 5. We would just call him a 5th degree. And once there's more than 1 variable, we would just call it a polynomial. So what I'd like you to do right now is pause the video and see if you can name the 4 at the bottom of the screen, giving their first name based on degree and their last name based on the number of terms. Come right back and see how you did. Okay, everybody, let's see how we did here. Highest degree is a 1, so he is a linear. 2 terms would be binomial. He's a linear binomial. highest degree is a 3. He would be a cubic, one-term cubic monomial. Highest degree is a squared, so he'd be a quadratic, 3 terms, quadratic trinomial. Highest degree is a 5, so he's going to be a 5th degree, and we're beyond the trinomial, so he's just a 5th degree polynomial. How'd you do? Okay, so now let's add a little bit of math in here. We're going to talk about adding and subtracting polynomials. Adding is the easier one. So if you look at this first addition we're going to do, there are 3 polynomials here. None of them are in standard form. It's kind of a hot mess. You can see here that they're out of order. Here they're out of order. See, they're all kind of out of order. But we're going to add these 3 polynomials. And when there's an addition in between, the parentheses aren't necessary, to be perfectly honest. Now, what we need to do is we need to find the sum. We need to add them. And then we need to write our answer in standard form. So the way that I like to do this is a Woodruffism, is I do them in order. So I find the highest exponent in here, which is going to be to the third. I have 4x to the third here, and I'm looking for other x to the thirds. And you'll notice way to the back is a minus 1x to the third. So I have 4x to the thirds, take away the 1x to the third, which you can write it as plus a negative x to the third, whichever you like. And if I have 4 and a negative 1, I'll have a coefficient of 3 x to the thirds. Now remember, our exponent isn't going to change when we add or subtract. It's only when we multiply or divide will that change. We're looking at 4 of these plus negative 1 of these is 3 of them. It doesn't change. Now I'm going to move on to the next smallest exponent. So I'm looking for a, whoops, up here a 2. There's the 5x squared. Oop, adding a 3x squared. So right now I have 8x squareds. Any more? Oop, and another 6. So the 8 plus 6 would give me a 14x squared. And you can see me writing it out here, which you are welcome to do if you need to. But if you can go through and kind of add left to right and do what I'm doing, that's fine as well. So now I need to look for x to the first. So there's a negative 1, no, ooh, and a negative 4, negative 1, and negative 4 would be negative 5x's, and that's it. And you'll see it right there. Now again, minus 5x or adding a negative 5x is the same thing, and you'll kind of see me writing it here. So now I'm down to the constants. So I've already done all these up. 9, take away 2 would be 7. Take away 8 would be negative 1. There's the minus 1 or adding a negative 1, and you can kind of see me writing it here. So if you can go from here to here directly, that's fine. And if you need that intermediary step, feel free to do it. Now your book talks about doing either the horizontal method or the vertical. So I'm just going to show you the vertical. It's not my favorite, but that doesn't mean you might not like it. So the first thing you do is you put all of the polynomials, the 3 of them, in standard order, and you kind of put them on top of each other. So you line up all the x to the thirds, all the x squareds, all the x to the first, and all the constants, and then you kind of just add down. So 4x and a negative x to the third, 4x to the third, take away an x to the third will give you 3x to the third, and there's the 5 plus the 3 is 8 plus 6, there's the 14x squared, and a negative 1, whoops, and a negative 4 makes a negative 5x, and 9, take away 2 is 7, take away 8 is negative 1, and you're seeing we're getting the same answer. Now your book in the directions will say use a specific method, throw that direction out, use whichever one works for you all the time. It does not matter to me. So use your favorite method. So let's just talk about subtracting. It's not that different, but it is the tougher because the parentheses matter. So here is a polynomial, which happens to be in standard form, taking away another polynomial. When I go to subtract this second polynomial, I am not just subtracting that first term, I'm subtracting everybody. So I'm going to take away a negative 2x to the third, and minus a negative becomes a plus. I'm going to take away a positive 6x, which would give me a minus 6x, and I'm going to take away a negative 8, and minus a negative gives me plus 8. So basically, everybody's sign in this second polynomial is changing. And then once I do that, the parentheses aren't necessary, and we go right back to doing the adding. So remember, the Woodruff method is to look for your highest exponent, which is the third. So I got negative 2 of them and a positive 2 of them, and that's it. So I'm going to have 0 of them, so that drops out of my answer. There's no x to the third. Now I'm going to look for my squared, 7x squared minus 6. Whoops, no, I'm sorry, there isn't one. So he just drops down in the answer. I almost got caught there. Negative 1, take away 6. So negative 1x take away 6x, you can see it right here, is negative 7x. And then 15, add the 8, would be 23. The number one mistake is right here, to put a plus 6x and a minus 8, to only subtract that first term. Okay, what I'd like you to do here is to pause the video and try these 3 on your own. And then when you're all set, restart the video and let's see how you did. Okay, let's take a look at this first one. The first thing I'm going to do is I'm going to grab that negative 8m squared and add an m squared to it. So did you get negative 7m squared? Then I'm going to go to the 2m, adding a 5m and getting a plus 7m. And then the minus 3 is just hanging out by himself. And that's in standard form because I started with the highest exponent. Now with the subtraction, the 2y squared minus y squared would give you 1y squared, and I made that coefficient the invisible 1. The negative 8y minus a positive 5y, negative 8y minus 5y is going to give me negative 13y, and negative 3 minus a negative 10. That minus a negative will become a plus 10. So negative 3 plus 10 should have given you plus 7. Now here, if I take that 9x to the fourth and go across, you'll notice he doesn't have a like term, so he's going to start the lead on our answer. And here I'm seeing an x to the third take away 4x to the third, and 1 minus 4 would give us a negative 3x to the third. I'm going to go back and catch my negative x squared plus a negative 6x squared would give me negative 7x squared minus nobody. I'm sorry, that'll just be a negative 7x squared. I'm going to go to an exponent of 1, so 7x plus 2x would be 9x minus the 3x would give me a positive 6x. And now I'm going to grab my constants, and I'm going across. There's a negative 9 minus a positive 8. Negative 9 minus 8, the constant would be a negative 17. So let's take a look at our next slide, but I'm just going to remind you of the mistakes that can happen. Remember, when we're adding and subtracting, that you don't change the exponent. And when you're subtracting, make sure you subtract everybody in the group. Okay, for this final slide, here's just a couple of examples in geometry where we would use this idea. So we have a triangle up here, 3 sides, and it's got a polynomial on each side. To find the perimeter, we'd have to add up all the sides. So the first thing I'm noticing as I go around that we have a 2x to the third, and that's the only one. Negative 4x squared and a negative 4x squared would make negative 8x squared. Now I'm just looking for my exponents of 1. I have a positive 3x, and a positive 3x would make 6x, and a positive 4x would make positive 10x. And now I'm going to go around looking at my constants. A positive 5 would be 10. Take away the 3 would be a positive 7. Now there's just an example in geometry where we would use this idea of adding polynomials. Now the next one is a pentagon, and it's missing a side, but I have the perimeter. So I have kind of the answer. It's like a backwards problem. I have the answer and I need to find one of the missing sides. So remember that the 5 sides added up would have to equal the perimeter. So the perimeter minus these 4 sides would give you the missing side. Why don't you pause the video for a second and see if you can figure that one out on your own. Okay, now that you're back, I would first add up all of these sides. And so you see I have an A and an A, which would be 2A. 4A, take away 2A, would have a, right there, a 2A. And then a negative 3 and a negative 3 would be negative 6. A negative 6 minus 8 would be negative 14. And a negative 14 plus 12 would be the minus 2. So the 4 sides added up would be this 2A minus 2. So if I took the perimeter, 4A plus 5, and subtracted those 4 sides, that would give me the missing side. So I take 4A minus 2A and 5 minus a negative 2, and I should get 2A plus 7. So that's a pretty big vocabulary lesson at the start, talking about naming polynomials using their degree and the number of terms. And then the second half of the lesson had to do with adding and subtracting polynomials. I hope this is a good way to start practicing all of these ideas, and I'll talk to you soon. Thanks for your attention, guys.